All right, so in this next section, Kaden, can you sit down, please, and join us?
Sure.
Thank you. Are you going to be in a mood today?
What's a mood?
Because I'm recording everything, so I need you to be a little quieter today. Yes. All right, so here we go. Today, our goal is to be determining if lines are running parallel. I want to go back, though you don't need to, and I'm going to talk about yesterday. Yesterday, every single one of them in your Delta Math assignment had a given of 2 lines were running parallel. It was on all of them. It said if M is parallel to N or if L is parallel to W. It always said the lines were parallel. And you had 4 relationships that you would use. You would say, well, if they're in the same spot or if they're corresponding, we get to say they're the same. And we called that the corresponding angle postulate. We said if they were alternate interior, then the angles are congruent. We said if the lines are parallel, then if they're alternate exterior, the lines are congruent. And then we also said if the lines are parallel, then the same side interior add up to 180. For all of those, it was if the lines were parallel. What was the if on all of them yesterday?
That they're parallel.
They're parallel. Today, that's going to be the then. So from last chapter, what's it called when we swap the if and the then? Converse. Yeah, so we're going to be dealing with the converse of everything you did yesterday. We are going to be switching everything. All right? So today, what we're going to do is hop on these notes, and we are going to switch our if and the then. So I'm going to hop up here, and by that converse, I want you to write right above it on that page in your notes. We are going to be swapping our if from yesterday, then. And yesterday, our if was always the lines are parallel. I'm just going to write P parallel to Q. And we are going to be switching those. So we're going to be concluding lines are parallel. Just so you know, all day today, we are concluding lines are parallel. So in your notes right here, I did not tell you those lines are parallel. It doesn't say M is running parallel to L. It doesn't say have those little runners on it. But you're going to learn that there's a way to force them to run parallel. Okay? So take a look at these angles from yesterday. Do you remember what those are called when they're both in their same spots? Corresponding. So if I can get those to be the same, you're going to force them to be the same. So if this is an 80, go ahead and put it on there. And this is an X. All right, go ahead and stick it on there. What they're going to ask you to do today is to force the lines to run parallel. And you're going to look at that and you're going to say, well, for corresponding angles from yesterday, we need those to be congruent. So if they are, we can say that the lines run parallel. Any other number but 80 in there for angle 2, L and M will cross at some point. The farther away they are, the sooner they'll cross. Like if I said, oh, this is a 79, it'll take them a while to cross, but they eventually will. But if I said this angle's going at 100 and, sorry, I'm on my dead spot on there, 150 degrees, they're going to cross pretty soon. But if they're the same, they'll never cross. So you're going to say, well, I need X to run equal to 80. Then I can say the lines are parallel. But you're going to have to justify it with a reason. So you're going to say by, and we're going to have 4 reasons. All right, so our first one says, if corresponding angles are congruent, then the lines are parallel. So go look over here in this next slot. Angle 1 is congruent to angle 2. They're telling me they're the same, right, Mallory? And furthermore, they're marked as the same. So I'm 100% sure angle 2 is the same as angle 6, okay? You get to now say these are running parallel. I can put the runners on it, or I can just use the symbols. But then we're going to write by. Yesterday, we worked with corresponding angles being the same. We said if the lines are parallel, then the corresponding angles are the same. We're reversing it. So instead of writing by the corresponding angle postulate, like we did yesterday, because we switched the order, we're going to write the converse of the corresponding angle postulate. I want you to put this word in a box. I'm going to highlight it. It will be on everything we do, the word converse. All right? Because we are not going to be told lines are parallel. We're going to conclude they're parallel. We're swapping yesterday out. Last hour, though, they did very well. Most of them finished in class because they were so good with it yesterday. So let's go up here and look at the other three. All right? So these are all from yesterday, but we're reversing them. Yesterday it said the lines are parallel, so. Yesterday it said the lines are parallel, so. And lines are parallel, so. This is going to say this happens. Now the lines are parallel. So take a look at this guy. If two lines and a transversal form alternate interior, go ahead and box that word in, that are congruent. If you can get alternate interior to be the same measure, you might want to put a little equal under there if that word stumps you sometimes, you get to say the lines are parallel. So let's go take a look up here at what's being given. In the middle here, it says angle 4 is congruent to angle 6. You should know from yesterday, oh, those are alternate interior, correct? And they're telling me two ways that they're the same. There's three ways they can do it. By either explicitly stating it, putting the arcs in, or maybe there's numbers on both of them. Either one of those three ways, Dylan, I'm 1,000% sure that angle 4 is congruent to angle 6. When that happens, you get to say, oh, these lines are running parallel. I'm putting the runners on them because that's what that means. But you don't say by the alternate interior angle theorem. That was yesterday. We swapped that. Okay, so instead of the lines being parallel, so alternate interior are the same, we're swapping it. Saying alternate interior are the same, the lines are parallel. It's just yesterday in reverse. All right? But what word do I have to write in front of my alternate interior angle theorem? Converse of. Yep, so go ahead and write converse of, and go ahead and put that in a box. Yesterday was, I'm going to repeat, if L runs parallel to M, then alternate interior angles are congruent. Today is, if alternate interior angles are congruent, then L is parallel to M. So it's yesterday's flipped around. And we did really well yesterday, right? So we'll do just as well today. So look at the next one. If two lines and a transversal form out alternate exterior that are congruent. So we need to know what alternate exterior are from yesterday. They alternate on the outside of the parallel lines. So right here, I'm explicitly told 1 is the same as 7. I even have the arcs in them. And if they're the same, then I can say the two lines are parallel. So here's my conclusion. I know you guys are running parallel. By. All right? And I'll say the alternate exterior angle theorem. But if you write that, or if on your quiz on Friday, you drag that in as your reason from, there's going to be a word bank with like 12 reasons in it. And if you're like, oh, those are alternate exterior, that'll be there. But that's not what this one is. Because we're concluding the lines are parallel, what word do I need? Converse of. So whenever you're concluding the lines are parallel, we are doing the converse of the original theorem. Do you see how I've said that word a zillion times? And I highlighted it and I boxed it in. Because do you think in my history of teaching this, kids just go, oh, they're corresponding, and click on corresponding angle postulate? Yes. So if you're using corresponding angles to prove lines are parallel, so like if on your quiz it says, angle 1 is congruent to angle 6, so P runs parallel to Q, and it says provide the reason. And Dante goes, okay, 1 and 6 are corresponding angles. And he's going to go, oh, cap. But because we're proving the lines are parallel, what should he click on? Converse of cap. You see the difference? So if you're concluding they're parallel, so let's go to the last one from yesterday. We said the ones on the same side and inside have to be supplementary. Let's remind ourselves of what that word means. Mallory, what does it mean to be supplementary? Do you remember? Yeah. So if I can get or force or it's given to me that the same side interior add up to 180, then the lines are parallel. So here they're telling me 3 plus 6 adds up to 180. And we're concluding the lines are parallel. So if that happens on your quiz on Friday and it says, give the reason, you're going to go, oh, same side interior angle theorem. And you're going to get it wrong. Because what should you click on? Converse of. And what's the trigger for that? Concluding lines are parallel. I said it a bunch, and you're going to write it a bunch. So I think it's going to get in your head, but it's just deadly if you're like, oh, corresponding angles, click, oh, same side. And if they're all converses, they're all wrong. Does that make sense? So you have to be really, really, really careful. Did I give you enough time to write that? All right, let's go to the next page. You'll finish in class today. I'm going to wait on the proof. I'll do that at the end. Okay, so we're actually going to go back, forward a page. All right, so we're going to use some algebra. It says, what is the value of x that'll force the lines to run parallel? So you're going to go over here. You're going to look at where they're located. And you're going to ask yourself the same question as yesterday. Do they have to be equal where they're placed? Or do they have to add up to 180? What do you think? Go ahead, you can tell me. I'm recording, but I don't think it'll pick you up much. What do you think? Yeah, I heard you. They have to add up to 180. You can even see they're not equal. One's obtuse, one's acute. But they're same side interior. And we were told yesterday that those are supplementary. So you're going to go like this. 2x plus 9, plus 111 equals 180. So we're going to say those two guys are supplementary. You're going to use your algebra. So we'll combine our like terms right here. And we'll have our 2x plus 120 equals 180. And then I'll have, how about, called on Jacob a lot yesterday. Alexandria, can you give me the 2 steps for solving this guy for x, please? Yep, so I'm going to subtract 120 from 80, thank you. And then what's the last thing I'll do? Divide by 2, right? So x is equal to 30. This is what I'm going to have you write today, though, on your assignment. Are you ready? You're going to write if x equals 30, if it's anything else. If it's 29.5 or 999, you can't draw this conclusion. But if x equals 30, then A runs parallel to B. Go ahead and write that down. Remember that symbol from a couple days ago. And you're going to tell me by which of those 4 theorems. Okay? So you're going to have to ask yourself, are those corresponding, alternate interior, alternate exterior, or same side interior? Go ahead, Courtney. They're same side interior. So, be careful you don't write same side interior angle theorem. Because we're concluding parallel, you're going to put in that word. What word? Converse. There we go. Right, myself? Converse of same side interior angle theorem. So we're going to find the value, and then we're going to, oops, I forgot an N on my then. Then we're going to write a little sentence at the end. And if you write converse of 16 times on your homework today, I'm hoping that on the quiz and the test, you're like, oh yeah, that parallel's got to trigger that word. All right, let's go look at the next one. Okay, it says, what value will force C to run parallel to D? Only one number in this whole world. Anything else, they will cross at some point. You're going to look at where they're located. You're going to use yesterday's stuff to go, oh, those are both in the top left, right? Who remembers what kind of angles they are when they're in their same spots? Corresponding. And you're going to say, oh, I need corresponding to be either equal or add up to 180. Which one is it? Equal. Okay, so we're going to force those to be equal. You might say, well, LaRude, the last one you had to add up to 180. That's because yesterday, same side interior said 180. Okay, these are equal. All right, now we'll have somebody besides Alexandria go ahead and talk me through. Go ahead, and Kaden, what would I do to solve this guy for the W?
What?
What would I do to solve this for W?
Add
Add 2, so he'll get a 57 equals 3W. And then what will your last algebra step be? He'll divide 57 by 3, which is what? 19, right? 19 equals W. But don't stop. We're going to write our sentence. Okay, that's the only number in the world that'll force these to run parallel. So we're going to say if W equals 19, then what can I conclude? C is running parallel to B. And then I'm going to say by which of our 4. Okay, so by, and then you have to decide what these were. You guys already told me that they were corresponding angles. So if Jaden goes like this on his quiz on Friday, W equals 19, and then clicks on the reason cap, what's wrong with it? Not the converse, exactly. By converse of, I'm going to put it in a box. All right? So everything you write today should be, this is parallel to this by the converse of. All right? Now, we do need to do one proof. We'll focus more on them when we start prepping for the test. I'll tell you what I want you to be comfortable with right now with the proofs. Okay? And you guys trust me, I think. Last chapter, you really nailed most of you the algebra proofs, like the substitution and the SAP and stuff. I will prepare you for them, just not in full today. I'm going to go through one, and we're going to see if we have the basics down. But if you're a little uncomfortable with the middle today, I'm okay with that. We'll get it squared away by the test, which isn't until November 5th. So we're going to just pepper the proofs in. Because if I slam you with them, you'd hate me. All right? It's just one today. You're nodding, right? Wouldn't you hate me if it was like proofs all day long? But we're going to do one of them. Let's see if you guys remember what we put right here. That you should know. Statements. Thank you. I am going to make some statements. And each one that I make, I shall provide a what? Reason, a mathematical reason for it. There are some things you should have down pat right now about your statements and your reasons. You should be 100% sure all the time what your first statement is, and 1,000% sure what your first reason is, and 1,000% sure what your last statement is. Those 3 are freebies. Right, Madison? So what is my first statement for this one? Go ahead, Madison. Yes, she is what I called last chapter, puking up the given. It just plops it up. You can't get that wrong. It's stated right there. And the reason for it is always the same thing. What is it, Avery? Given. Okay, that's for free. You should be very comfortable with that. Correct? Down here, what do I have to provide logic to conclude? Go ahead, tell me. L runs parallel to M. Now I'm going to tell you there's actually something else here. There's only 4 ways I can prove lines are parallel. Okay? Converse of, converse of, converse of, and converse of. Correct? So I actually do know that this has to be the converse of something. That's actually all right now. And one other tiny thing I want you to be comfortable with. Right now, I think most of you want to write converse of alternate interior angle theorem. Am I right? But that's what I'm trying to prove. So that's like in a dictionary looking up what troubled means, and it says troubled. Like it's defining it with itself. So I can use anything else in my mathematical definitions and theorems except the thing I'm trying to prove. Does that make sense? You can't prove it with itself. So I need to use something else. So what other angle is on there? 2. Okay. What's angle 2 the same as? 4 and 6. Do you see how you, correct? So angle 2 is the same as 4. I agree with you. Right? And also angle 2 is the same as angle 6. Would you agree? They told me angle 4 is congruent to angle 6. Well, here's what I need to do. Angle 2, let's write it down. You guys told me that right off the bat, is the same as angle 4. Somebody said that. So great. If you weren't comfortable with that, that's fine. You should have been comfortable with everything up to the person who said angle 2 is the same as angle 4. By November 5th, the day of your test, you need to be comfortable with that move. Let's see who remembers the reason for that, though. Oh, I'm very impressed with that. I'm impressed with that VAT. What does VAT stand for? Vertical angle theorem. Excellent. Now, you might not know to state this. You might not be comfortable with this statement, but you should be very comfortable with the reason. So I'm going to make the next statement. Because you play fill in the blank on the actual test. Remember when you took it, you were filling in the blanks? Makes it way easier. So we practice it a little harder. I'm going to say, oh, year 4 and year 4. So you see this statement. You should be very comfortable supplying the reason. Don't blurt it. You might not have known to make this statement, but if it's made for you, at this point, you should be very comfortable with what it is when we say, Jake, get out of here. Right? You know that one, don't you? You better not forget it. You are my example every time. Right? What property are you the example of, Jacob? Transitive. Yes. Transitive. Now we only have to decide if I've got angle 2 the same as angle 6. So go ahead. It's our last thing we're going to do today. Nice short notes. What is that the converse of? I can say, oh, 2, you're the same as 6. You guys have to run parallel because you're corresponding angles. But I don't write cap. Why not? Because I'm doing it in reverse. So this went really well, don't you think, Miss L? Like I hear a bunch of different people. You don't need to be that comfortable, though. You need to be comfortable with about 4 of these slots right now. And I'm only doing 1 today. And there's none of them on your homework. We'll deal with those later. But converse of, and you guys said cap. Perfect. All right, so I'm going to pass out the worksheet. I'm going to show you, I will hand this back and not give you any points unless it's written exactly as I say. Most of you will finish in class, so don't let the writing be like, oh, it's going to take me forever. You should finish. I think I will send, after I go over a couple of them, maybe 1 per row to go with Miss L and do a few more together. 1 or 2. Just for the writing part, just to make sure, because I'll be walking around and she will, and we'll get to everybody that way. All right, so let's go take a peek at the ones, how I need you to write your answers for these. I gotta go find mine, guys. All right, so yours says on the top, yours says to write something. What does yours say? Oh, here you go. It says justify, right? Do you need 1 more? Do you see how it says justify your answer with? Okay. On the bottom, let's write what those are because you have some extra space on the bottom. So put a nice big box under here. You are going to justify your answers with one of these 4 things. Converse of. Converse. If I could count how many times I said converse today. Converse of. Converse of. Converse of. All right. We'll be writing converse of 16 times because there's 16 problems on here. All right. For each one, you're going to choose whether it's the converse of the corresponding angle postulate. So go ahead and write cap. I'll allow you to abbreviate it. Just make sure you do so correctly. What's one of the other ones besides corresponding angles being the same? What other one could I get to be the same? Same side interior have to be supplementary, but we do have a same side interior angle theorem. Oh, you know what? Let's do this. Let's put in a little corner. These have to be equal. These have to add up to 180. Another one would be our alternate interior angle theorem. I have to get those to be equal. What one am I missing? Alternate exterior. Yep, so alternate exterior angle theorem. Do those need to be the same or add up to 180? Our alternate exteriors. Do you remember? Same. Yep. All right. And I'll wait till you're done writing, and then we'll go do 3 of them together, just so you know exactly what you need to write, because I will be handing them back to you and giving you a missing until they're written correctly. So it's not just about finding what you need to find. One thing I don't like is I don't like these question marks, so let's go replace them with X's. X. I think they are in the algebra ones, but until it goes algebra, there's a question mark there. So all of these question marks are going there. All right, we're going to do number 1 together. All right, it says find the measure of each angle. So you're going to say X equals, you're going to find the measure. You're going to go, oh, those are corresponding. From yesterday, for the lines to run parallel, it would have said if the lines are parallel, then corresponding angles are the same. So what does X have to be? 130. But you're going to write yourself a note. This is what you're going to write. If X equals 130, you can box in your answer if you want. Then, look at what I'm supposed to conclude. U is parallel to V by, and you're going to go look down there. And what word are you going to write for sure? Converse of. All right, so let's write that. Converse of, and you have to decide which of the 4. Did you force alternate interior to be the same? Did you force alternate exterior to be the same? Did you force same side interior to add up to 180? Or did you, there it is. It's a lot to say. Geometry is a lot of words. Sometimes it makes me crowded. But, so you're going to write converse of, yeah, number 1 is done. We're going to go down to the bottom right and look at number 8. You are supposed to get U parallel to V. So if I were you, I'd make those really dark on your paper. I highlighted them. But that middle line's got nothing to do with the problem. It's just to mess with your visuals. Okay? So I would go take U really dark, V really dark, and then do the slicer also really dark. And then just now ignore everything else. So I shall be ignoring that middle line. And then you're going to ask yourself, what are these? They're inside, so they're interior. Yep. These are alternate interior angles. What do I need to force them to be? Equal. Exactly. So you're going to go like this. X equals, you guys just said you have to force them, but that's not, if you only write that, I don't think you're going to get the gist of what the difference between yesterday and today. So that is the only number. So you're going to write if X equals 58. If it's anything else, we're out of business. You're going to write then. What am I supposed to conclude for all of these? Go read it. It will be, but I need to conclude. Go read the sum of the problem. U, yeah, there you go. U is running parallel to V by, and what word are you going to write?
Converse.
Awesome. Converse of, and which of our 4? Alternate. Do we got it? All right, let's flip to do an algebra one. So you're going to write by converse of alternate interior angle theorem. Let's go do down here on the bottom. Let's do, how about, ooh, I like 15. Okay. When you start 15, you're going to be going, that's a lot of stuff in there, correct? I need U to run parallel to V. So if I were you, I'd darken that with your pencil. Make it stand out to you. I'm going to do it nice and red. Then I need this, sorry, I should put mine. Then I need the slicer that my stuff is on. So I would do this one really dark also. What are you going to do with that other line in there? Get it out of your eyesight. Don't look at it. It'll mess with your head. All right, so U and V are the important lines, and all my stuff is on the slicer. So then you have to go here and you have to say, well, what do I need these to do? Do I need to set them equal, or what's our other option? Add up to 180. Which one is it for those that are in the same spot? They're equal. Yeah, they're both in that, I'd say, top right of the clump of 4. Agreed? So I need to say 11x minus 2. I need to force U to equal 130. There's one number in the world that will do that. Any other number will tilt my lines. So go ahead and talk me through the algebra of it, Libby. That should be a 130. My 3 looked almost like an 8, and that's deadly. It's 100 there. All right, go ahead, Libs.
You add 2.
I will. I'll add 2. I'll add 2. Right?
And then bring 11 down.
11x equals 132.
And then divide it.
Divide. Can somebody divide 11 by 132? I think it's 12.
12.
Is it 12? 1, 2. Yeah, it's going to be 12. You're not going to quit or I'll hand it back to you tomorrow. It's not only, really, that's the least, that's yesterday, and you're going to get the 2 confused if you don't write yourself a sentence. You're going to write if x equals 12, then what were we supposed to do on this assignment? Force you to run parallel to who? V. And that x is the only one we'll do it by one of our 4 theorems. What am I going to write for sure? Converse of. All right? And then what kind were those? Cat. Are we good? All right. Go ahead. I will take, let's do Jacob. Let's do Stephanie. Let's do Mallory. Let's do another Jacob. I'm feeling the Jacobs today. Let's do Harmony. And maybe, no. You guys can go with Miss L. She'll talk you through a few more, and I'll talk you guys through. Who did I pick? I picked a Jacob, a Stephanie, a Mallory. Who did I pick? And another Jacob, and a Harmony, and a Noel. All right? Go ahead.
Wait, you shave it all off?
Go ahead, the other Jacob.
No. You had a little like this.
Sweet.
I think you shaved it
Come
all off.
here. Do you want to go? Andrew, do you want to go? Or do you want to stay? Go or stay? Good, you can go. You want to go or stay? I'll pick different ones tomorrow. Just to try to make sure we get it. When you have enough time to finish. Do you want a Carter go or stay?
Can you go?
Yeah, if he wants to, he can swap out. Doesn't really matter. I just randomly grab one per row. Brian, how about you? Stay or go? You want to talk through them with Miss Ella? How about you? You stay? You want to stay? Nathan, do you want to stay? Portland, you good staying?
Yeah.
We're good? Okay. I'll start doing this a little more just to spread us out, and I'll just keep different people tomorrow. Although tomorrow's your deep breakfast. Alright, and I forgot to stop my recording. It's gonna seem like an awful lot of notes.
Still going.
Infinite geometry. Yo, you get this.